This is lesson number 4-9, and this is meant to be working with your graphing calculator, so you need to have your graphing calculator ready. There are also a couple of additional videos about specifically how to use your graphing calculator for some of the problems in this lesson. Not all of them, but for some of them. Okay, for the beginning of the lesson, we are going to want to reset our calculator, so make sure that your calculator has been cleared out so that you're not messing with any other previous problems. And then the keystrokes that I'm going to tell you is second plus, and then you can do 7, 1, 2, or 7, 2, 2. Either of those are fine. And this is just telling you how to clear. And so you want to just remember that. So second plus 7, 1, 2 is what I do, or you can do second plus 7, 2, 2. It virtually does the same thing. So for this first problem, all we're going to do is we're going to practice graphing and making a table for this equation. So just remember that if we're looking at y equals 400 and then times 0.85 to the x power, because this 0.85 is less than 1, this is talking about decay. So I know that it's going to be going down like that because of the type of equation it is. So what I'm going to do is go to my calculator. And there's not a video for this one, but I'm going to go to my calculator, and in my y equals menu, I'm going to type in 400 parentheses 0.85 to the x power. And type that in. You're going to set your table, and you want your table to start at 0. And you want your delta table to be 5. So we're going to say table start is going to be 0, and delta table is going to be 5 because we're going 0, 5, 10, 15, 20. And then when you do that, you're going to do second and then graph. And then you're going to get your numbers. So if you're doing this correctly and you've typed everything in right, then the numbers that you should get, and it says round to the nearest whole number. So the numbers that you should get for this are 400, 177, because remember it's going down, 79, 35, 16, 7, and 3. Now we're not going to label our x and y axis because there's no context to this problem, so we're just going to start at the 400. We're going to go down to 177, and then down to 79, and then 35, and then 16, and 7 and 3. So you can see that it's approaching 0. It's getting small. So it drops a lot at first and just kind of evens out. Okay, now number 2, it says use the table to graph this new equation. So we're changing the 400 to a 250, but the 0.85 is staying the same. So my rate is staying the same. So these are dropping at the same rate, but we're going to start this one lower. So I know that my y-intercept should be 250 when I do this. So you're going to type in this equation, so y equals menu, and then you're going to type in 250 times 0.85, and then to the x power. So you're going to use that button that looks like a little arrow that goes up. It's just the caret key is what it's called. And then to the x power. And then you should be able to get the numbers. 250, of course, is the y-intercept, and then 111, 49, 22, 10, 4, and 2. So if you need to pause this video and make sure that you're getting those numbers, you don't want to just copy down my numbers. You need to make sure that you're getting these numbers yourself. So you can go ahead and pause the video and make sure you're getting those numbers. We're going to graph those numbers, so starting at 250 and then going down to 111, and then to 49, and 22, 10, 4, 2. So they're both approaching 0, and as it gets closer and closer to 0, they're looking like they're almost the same thing. And that's how exponentials work. Number 3, it says, how did the graph change when my initial value went from 400 to 250? And so we can see that instead of starting at 400, we changed to 250. But other than that, that red graph, if I just shifted it down, it would be where the purple one is. So we're just going to say that it just moved down. It actually moved down 150 units. But we can say it started lower or started at 250 also. And I got the 150 from saying 400 minus 250. That's a difference of 150. So it started lower, but it's still going to be decreasing by 15%, because remember that the exponential decay, it's the 400 and then 1 minus 0.15, and that's where I'm getting the 0.85, by the way. Okay, the next thing, it says use the table to graph 400 and then times 0.95. So what's happening here is I'm doing 1 minus 0.05, so now I'm only losing 5% instead of 15, and that's where I'm getting the 0.95. So this one is not going to be going down as fast. And so this really goes back to understanding how exponential equations work. But you're going to type this in your y equals menu, and then you're going to put it in your calculator. And so what's happening is we're starting back at 400 again. But it's not going to go down as fast, so I'm not expecting this one to be 177. I'm expecting it to be more than that, and quite a bit more actually. It actually comes out to be 310. And then 239, so it's taking longer to get down as far, and that's just because it's decreasing at a slower rate. And so you can see quite a difference if you compare the red with the blue. So what I'm going to do now is go to my graph, and I'm going to graph this starting at 400, but then I'm only going down to 310 and 239. 185, 143, 111, 86. So it's going to still go down, and eventually it's going to approach 0. It's just going to take longer to do that because it's not decreasing as fast. So when I go and answer the question for number 5, how did the graph change when the rate went from 0.85 to 0.95? We're going to say it decreased at a slower rate, or you can say it did not decrease as fast, or it went down slower. Okay, so something like that, but it's all about the rate here because that's what changed. Okay, number 6, there is a video that goes through the calculator directions for this. We are going to be first graphing this equation. It's an exponential equation, y equals 2 to the x power. We've learned from the past, though, that this plus 5 is just going to lift that y equals 2 to the x power up 5. So it's just going to be lifted up a little bit from what we would expect if we just did that one. In fact, you could try it on your calculator where you do the first y equals, you could do 2 to the x power, and then y sub 2, you could do 2 to the x plus 5, and just kind of see the difference between the two. And so that would just be interesting to see. But we're going to type that in, and if you're doing that right, the numbers you should get, it does not say anything about rounding here, so I'm not going to be rounding. There's not that many decimals anyway. But you should get at -3. Remember, so your table start, this time you're going to change that to -3, and your delta table is going to be going by 1. So you need to make sure that you make that change. Otherwise, your table is not going to look like the one on the paper. So you need to be paying attention to what that looks like. So I'm going to get the 5.125, and then I'm going to get 5.25, and then 5.5, 6, 7, 9, 13, 21, and 37. And so I don't have any context, so I don't need to label my x and y axis, but at -3 I'm going to be at 5.125, and then 5.25, 5.5, and then 6 finally by the time I get to the y-axis. Then I'm going to go up to 7, and then I jump up to 9. And then we start jumping a lot faster because that's how exponential growth works. And so if I graph this equation, it's going to be looking like this. Now, you don't have to graph this, but let me just show you that if you did y equals 2 to the x power, that one's going to start at 1 because that's like a 1 times 2 to the x. And then it's going to double, so it's going to go to 2, and then it's going to go to 4, and then it's going to go to 8, and then it's going to go to 16. And so before it was at 1, it was at 1/2. And so it's going to be looking like this. And so what that is if you took that red graph and you lift it up 5, it's going to be exactly where that blue graph is. And so all of those are just moving up. So it's kind of like the blue one is just getting a head start. And so that's just, by the way, that's how that works. Okay, now the next one we're going to graph is we are going to graph y is equal to 2 to the x power minus 1. So instead of a plus 5, we're going to be at -1. So we're going to actually drop now. We're not just going to drop from the original 5 down 1, we're going to drop from what it was originally down 1. So I'm expecting my y-intercept to be at 0. If you don't really understand how I'm expecting it to be at 0, that's okay, but that's what it's going. It's going from a positive 5 to a negative 1 is basically what's happening. So we're going to be dropping a difference of 6. Okay, so when you put y is equal to 2 to the x power plus 1 in your calculator, remember to make sure if you are on a TI-84, you need to make sure that when you do 2 to the x power, you need to get out of the exponent and you need to get your minus sign down there. Because if on a TI-84, if you're not careful, it's going to look like this, and that's going to be a very different set of numbers. Now, if you're doing a TI-83, you don't need to worry about it because when you do 2 to the x power and then minus 1, because of order of operations, it sees it the way that we mean it. So part of this is just knowing how the calculator works, and that's part of why we're practicing this. So when I do that and I put this in, the numbers we should get, negative 0.875, and then negative 0.75, negative 0.5, 0, 1, 3, 7, 15, and 31. So if you're not getting those numbers, you need to go back and look at how you entered your equation in your y equals menu, because that's probably the issue. So if I go to graph that, I'm going to start at negative 0.85, so that's going to be down here, and then negative 0.75, negative 0.5, and then 0, and then 1, and 3, and 7, and then up to 15, and then up to 31. I actually don't have space to do that on my graph, so I'll just graph what I have. And so that's how that's going to work. So again, if I just took that red graph and if I just lifted it up 6 units, then it's going to be where the blue graph is. And so what happened when I changed it to 2 to the x minus 1? Basically, it dropped. It started lower. It started at negative 1 instead. Or sorry, not negative 1. Started at 0 instead of 6. So that's my 0 and that's my 6. And so it's not a 5 and a 1 because of where y equals 2 to the x would have started. So I know that's a little bit confusing, but you can compare at the y-intercept level and see how that compares to. That's another way that you can look at that. Okay, the next question is graph y equals 2 to the x power plus 9. So this is actually going to be higher than my blue graph. It's going to start above. And so since 9 is 4 units higher than 5 is, I would expect that this point right here is going to go up 1, 2, 3, 4. This is where my y-intercept is going to be on my new one. So let's try that. Put this in your calculator, back in your y equals menu. Remember, y is equal to 2 to the x power and then plus 9 if you're on a TI-83. If you're on a TI-84, do 2 to the x power, but then make sure you get out of the exponent to put a plus 9. Do not put the plus 9 as part of your exponent. That would be wrong. Okay, so when you put that in your calculator, if you do it right, the numbers that you should get are 9.125, 9.25, 9.5, 10 is my y-intercept, 11, 13, 17, 25, 41. And so I'm going to go and start that. So 9.125 is just barely above the 9, 9.25. Oh, whoops, I started too soon. And then 10 is my y-intercept, and then I'm going to go to 11, and then 13, 17, and then 25, and then I'm off the graph, so I'm going to go ahead and graph that. And so if I took my blue and just lifted it, it's going to be exactly where the green one is. And so when it says what happened to the graph when the original was changed to that, it's going to start 4 higher. So it's kind of like we get a head start. And so the be specific part, that's where we need to say 4. So the next one, it says, without a graph, predict what would happen to the graph if you took this one that would be my red graph, and changed it to a y equals 2x plus 17. What's going to happen to that? So I want you to pause the video and think about that and write where do you think the y-intercept is going to be? What's going to happen if we went from a -1 to a plus 17 as what's being added on at the end? Okay, what you should have written is it's going to start 18 higher, because the difference from -1 to a positive 17 is 18. You could also say that the y-intercept will be at 18 instead of 0. Okay, so it's starting 18 higher, and so one way or another you need to say that. Okay, this last page is just kind of an exploration, some things that are good to know about a graphing calculator. A graphing calculator, we can actually make graphs on it, and we haven't done that yet, but we're going to right now. So we're going to start with a linear equation, y equals 3x plus 5, and we know already that we were going to start at the y-intercept. You're going to go up 3 and over 1, so you know that your graph's going to look like that. But let's have our calculator do it so we can kind of start to see what the calculator can do. So I do have another video on this specifically, so I'll just go through this quickly, but you might want to watch the other video if you're not sure how to make this work. So you're going to go to your y equals menu, and then you're going to type in the 3, and then remember for your variable you just do that button that says xt theta n, and then plus the 5. And then you're going to hit the graph button. Now before we've done second graph because we were doing the table, but you're not going to do second this time, just do graph. And so you should see a line that looks like you expect. Now if you don't, then you need to go back and check a couple of things. And so if you're not seeing what you need to see here, then I would suggest going back and looking at the graphing calculator video, because I gave you a couple of troubleshooting tips on there, what to do if it's not showing like it should, but there's a couple of things that you need to check to make sure. Now if you are not sure, one good thing you could do is just reset your calculator, the second plus 712. That might be a good thing to do, just to reset everything if you're having problems with that. Okay, then we're going to practice zooming in and zooming out. So if we zoom in, we might just want to look at, maybe just that part of the graph. If we zoom out, we might want to look at a whole bunch more. And so just depending on what we want to do, we need to practice doing that. So you're going to hit the window key, not second window like we've done to set up our table, but just window. And we have an x min and x max. Now min means minimum, so you have to do the smaller number there. Max means maximum. So if I want my window to be very large, and so instead of being at -10 and +10, maybe I want to be at -50 and +50, I have to do the -50 on the min. If you switch those, your calculator will say error, and it will not graph anything. So you need to tell the calculator, we're going to practice zooming out, so we're going to go -50 to +50, x min, x max. Then we're going to do the same thing with the y min and y max. Then if you hit graph, you should see a much larger window. Okay, you're going to see it like all the little marks are going to be like really small because they're going to be so close together. You're going to have 50 on each end. And so that's zooming out. Now if you want to zoom in, okay, then we only want to look at, maybe this smaller portion of the window right there. So if you go from -5 to +5, again, you've got to make sure the smaller number is with the x min. The larger number has to be with x max. That's telling me the minimum point of my x value and the maximum point of my x value. Same thing with the y, and then you're going to graph, and you're going to just see this zoomed in region of the graph. Again, you might want to watch the video on the calculator because I show you with the calculator how that's going to look. And so there's a question about the y-intercept, and if you're doing this zoomed in, it's going to be at the very top of your screen. And so if we wanted to see the y-intercept a little bit better, we could zoom out a little bit more, so maybe practice doing that. Again, the whole point of this is to practice using your graphing calculator, and so if you're just copying down what I'm telling you, you're not really learning how to use that graphing calculator and missing the whole point of this. So please pause and make sure that you're checking how to use this calculator, and again, watch the graphing calculator videos if you need to. Okay, this last part, this is just for you to practice using your graphing calculator, and so you're going to be practicing typing in this equation in your y equals menu. And then you're going to zoom in or zoom out so that you can see what it's doing. And so you're going to sketch the graph right here. So sketch what you see on your calculator. If you don't see anything, or if you don't see very much, so like if you see something like that, you might want to adjust your window so that we can actually see what's happening, because you need to see a better picture. Okay, so you want to see a better picture. How does that look? And so you're going to do a couple different ones. Now, the first two are linear. The second one, you can see that that one is not linear. It's actually going to be quadratic. So if you remember me telling you about quadratics, it's going to look like this. You just need to figure out where is the x and y axis in relation to that. So I'm not going to tell you where that is. You're going to go and put that in your calculator and find out. Number 11 is an exponential graph. And I know that because of the way it's set up. When I have x in the exponent, that's an exponential. So it's going to be exponential growth. So it's going to look something like that. But again, you need to show me where it is in relation. 12 is also exponential, but this one's decay. And I know that because of the number inside the parentheses. It's decaying quite quickly, so it's coming down like that. For number 13, what we want you to do is just make up your own equation. So make up something. It can be exponential or linear or quadratic, but just make something up that you're just curious, I wonder how that would look. And then write down what the equation is that you just wrote. So write y equals and whatever you're making up. And then just draw a picture. What does that look like? So make sure you've got your x and y axis so that we can see like what you did. And then you can show us, like what did you graph. And so make sure you have your equation plus your graph on that one so that we can see what you did there. And this is just meant for you to explore with your graphing calculator.